So last class we had started the discussion of sequence and series, and here we discussed that we can have any sequence. For example, this 2, 4, 6, 8, 10. This is a sequence, and 2 plus 4 plus 6 plus 8 plus 10. This is a series associated with the given sequence. Now, if we are talking about the sum of the series, then we will write it this way: sum of above series, that is equals to, that means the addition of each and every term, just like 2 plus 4, 6, 6, 12, 8, 20, 30. This is the sum of the series. So the clarity, like, are you having the clarity that this is sequence, this is series associated with the sequence, and this is just nothing but just the sum of the series, Nabila?
Yes, sir.
Okay, so yeah, this is how we represent. Now when we are having the terms like this, suppose we are having a1, then we are having a2, then we are having a3, just like that we are having till ak. This is a sequence. Okay, sequence where the terms are a1, a2, a3, a4, okay, till ak. Now if we want to represent the series, we can write it a1 plus a2 plus a3 plus a4, like that, plus, okay, dot dot dot, plus ak. This is a series associated with the given sequence. Now if we have to write the sum of the series, then there is another way also. Yeah, we can write it in a statement form like this, or maybe we can write it this way as well, by using this sign. This sign is called sigma sign. This sign is sigma sign. The way you know this is theta, the way you know this is phi, the way you know this is alpha, the way you know this is beta. Now I am telling you this is sigma. Sigma. Okay. This also has been taken from Greek alphabet and all, and we are using it to represent the summation. Okay, the way you know alpha beta we use for representing the zeros. In general, theta phi we use for representing the angles. Similarly, this sign, the sign which I have written over here, and I am telling it is sigma, sigma. This sigma will be using for representing the summation. So if we have to represent a1 plus a2 plus a3 plus a4 till ak, then we can use the sigma notation for representing the summation, and we can write it this way: summation of all ai, where I starts from 1 and ending at k. We can represent this thing, this one, as this one. Making sense?
Yes, ma'am.
Okay, now I'm not showing you what will be the expansion of this summation of I starts from 1 to k, because that summation we are having on the left side of the screen, the box one. Getting it?
Yes, ma'am.
Okay, so I'm telling you the expanded form is here and the compact form is here. Right one is the compact and left one is
Yes.
the expanded one. Both are exactly the same thing. So just in case we'll be having, let me show you. Just in case we will be having summation of, wait, let me take a question. Summation k is equals to 1 to 11, and the terms are 2 plus 3 to the power k. if we are having something like this, then we have to understand that this is nothing but just here k will keep on increasing. So actually when we will write the expanded form, we'll be having 2 plus 3 to the power 1 added with 2 plus 3 to the power 2 added with 2 plus 3 to the power 3 added with 2 plus 3 to the power 4 added with 2 plus 3 to the power 5. Making sense, Nabila?
Yes, ma'am.
2 plus 3 to the power 11. Okay. Here our k is ranging from 1 to 11. And each time you have to write the complete thing. Okay. If I'll give you just a moment. If I'll give you something like this, that k is ranging from 1 to 5 and you have to find, let's say 2 to the power k, just that. So you will be finding the summation of all 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5. If we are having, suppose the same thing, just like 3 plus 2 to the power k, and then again k is ranging from 1 to 5, then you will be having, okay, this bracket 3 plus 2 to the power 1 plus 3 plus 2 to the power 2 plus 3 plus 2 to the power 3. Okay, plus, so it's not like we will just 3 doesn't have anything, so we will write 3 only one time. No, summation means every time this bracket will continue itself. Making sense?
Yes, ma'am.
Okay, yes, Manvi. I was explaining the last day concept and a notation I was introducing just now, that here we are having a sigma notation which represents the summation. Okay, so just a moment. Let me introduce over here. So we understand already that when we are having 1, when we are having 3, when we are having 5, okay, this is nothing but just a sequence. Okay, sequence. Now if I will write 1 plus 3 plus 5, this is nothing but series associated with the above sequence. And when we will write this, okay, when we have to write the sum of series, yes Manvi, to you I am explaining, when we have to write the sum of the series, we'll be writing the summation like 1 plus 3, 4 plus 5, 9. This is the sum of the series. So this things is already clear to you, which we were discussing in the last class. Now if we are having a1, a2, a3, dot 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 ak, then this is nothing but just a sequence. Okay, now if we will write a1 plus a2 plus a3 dot 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 plus ak, this is the series associated with the given sequence. This series is associated with the above sequence. Now if we have to find the sum of the series, so in a statement form we can write the sum of series, that is equals to, okay, all added together. Here I can't see the number, so I'm not able to add. Okay, but there is another way also to represent the sum of the series. Okay, this addition can also be represented in another way. Okay, and that other ways we can use this notation. This is for the very first time maybe you are seeing this notation. This is called sigma notation. Sigma, this is sigma notation. The way you know theta represents angle, phi represents angle, alpha represents roots, beta represent zeros or roots. Okay. Similarly, today I am telling you this is a new symbol for you, which the name of this is sigma notation. And we will be using it to represent the summation. Summation. So if I have to represent A1 plus A2 plus A3 plus, okay, AK, then I'll be representing with the help of sigma like this. Sigma of all AI, where I is ranging from 1 to K. This means A1 plus A2 plus A3 plus dot 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 AK. Getting it, Manvi?
Yes, ma'am.
Okay, if you will be having summation of all 2 to the power I, where I is ranging from 1 to 5, that means you are having 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5. If this will be given, then you are supposed to write this one by yourself, by understanding that this is summation sign. This is the sigma notation, which is representing the sum of all 2 to the power I, where I is ranging from 1 to 5. Getting it?
Yes, ma'am.
Okay. In case you are having just like this 2I or maybe 5I, where I is ranging from 1 to 3. So you will be having 5 multiplied with 1, added with 5 multiplied with 2, added with 5 multiplied with 3. Is it making sense to both of you, Nabila and Manvi?
Yes, ma'am.
Okay. Now, if in case I will write the summation of all 5 plus 2, and again I is ranging from 1 to, let's say, 4, so you will be having this bracket. First time you will be dropping at the place of I 1, and yeah, 2 will remain as it is, added with 5 into 2 plus 2, 2 will remain as it is, added with, just I will keep on changing from 1 to 4. So we I am just taking the value of I1, then 2, then I'll take 3, and then we'll be taking 4. Is it clear, Manvi and Nabila?
Yes, ma'am.
So when this will be given, we are supposed to write this by ourselves, and then we are supposed to add them all to give the final answer. Okay. So yeah, let's continue with the discussion. We will be doing questions like this. Further,
Okay,
if we
ma'am.
have to add them all, further, if you have to add them all, then you can add it. Okay. You can add it. This is nothing but just calculation now. Can you see that? Here just calculation is left. Already we have decoded. Okay, a notation was given, we have decoded the language. Now whatever we are having in hand, can you see it is doable even without explaining? Okay, I'm not explaining it, but still you'll be able to do it, right? You'll be able to find the final answer, right? Right? Yes or no?
Yes, ma'am. Yes, ma'am.
Now let's see a few questions from here, and then I'm taking the concept of GP, geometric progression. So actually, in your book, Manvi, and in your book, Nabila, both, okay, of you are having the same, like suppose T of n. We also represent the sequence like this, that nth term of the sequence can be given to you like this, or maybe like this, the way you used to represent the polynomial. Recall that you used to represent the polynomial like this, or maybe like this, or maybe like this. Okay, so similarly I'm telling you, we can also have the sequence represented in this manner, that nth term of the sequence, either it will be given an is 2 plus n is square, and then you have to find the first term, the second term, the third term, the fourth term, or maybe it can also be given a and in bracket n, just like polynomial, just like in function chapter I will tell you that this way we represent the function. So just like polynomial or just like function, we can also have we can also have an in this manner, and you should not get confused, because this one and this one is the same thing. Getting it?
Yes, ma'am. Yes, ma'am.
Now the question is like this: write the first 5 term. If a1 is given as a 3, an is given as 3 a n minus 1 plus 2 for all n bigger than 1. Okay, we have to write the first 5 term. You can clearly see first term is given to you, a1 is given. We have to find A2, A3, A4, A5, right? That will be the first 5 term of this sequence. Sequence doesn't mean it has to be in arithmetic sequence only. We have so many different types of sequence, okay? And it's completely fine. Sequence of prime numbers, sequence of, okay, Fibonacci sequence, or any other random sequence. Sequence can be anything. Yeah, arithmetic sequence is one of the variety you have seen in your previous class where the differences has to be same. But sequence can follow any pattern. So here we have already a1 is 3 and an is 3 a and minus 1 plus 2. Let's try writing the first term is given. We will try finding the second term. Second term according to this pattern, a2 will be at the place of n I am substituting 2. We'll be having 3a. N minus 1 means you have to drop at the place of n 2. Why? Why 2? Because we want to find the second term. Okay, we want to find the second term. That's why wherever we are seeing n, we are placing 2, okay, at the place of that, plus 2. That will be 3a1 plus 2. Now we already know a1 value is 3, so we will be dropping it over here. A1 is 3 plus 2, and we will be getting 3 times 9, 10, 11. A2 is 11. Are you getting it, Nabila and Manvi? Please
Yes.
find A3, A4, A5.
Done.
What you got, A3?
Yes, ma'am.
Yes. What is A3, A4, and A5?
A3 is 35.
Hmm.
A4 is 107.
Hmm.
A5 is 323.
322, Nabila?
23, ma'am. 323.
33. Yes, Manvi, what you are getting?
Ma'am, I got the same thing.
323, ma'am.
Okay, 323. Yeah. Okay, so this is how so many questions are there, and you have to find the first 4 term, first 5 term. Now we can start with the GP, geometric progression. So the way you know arithmetic progression means it's just a sequence, but that sequence must follow a certain rule. That rule was the common difference. I mean, the difference, the gap between the consecutive term, the gap between first term and second term. That means A2 minus A1. That has to be same as A3 minus A2. That must be same as A4 minus A3. If that pattern is getting followed, then we can say the given sequence is in AP. The given sequence is progressing in arithmetic. Okay, that's called arithmetic sequence. We call it arithmetic sequence, or we call it arithmetic progression. The way it is progressing, the progressing doesn't mean that it will progress and we will keep on having a larger number. You have also seen such sequence where the sequence was decreasing. Decreasing means you have seen such sequence where the number were continuously, okay, lesser. Maybe the first term is 5, the next term is 3, the next term is 1. This type of sequence also you have seen. So progressing means it is just continuing, and we were saying this is in AP. Okay, here we are having another type of sequence, that's GP. We will be calling it geometric progression, or we will be calling it GP. Okay, so here the sequence will follow a certain pattern. It will look like this: 2 will be there, maybe 4 will be there, then 8 will be there, then 16 will be there, then 32 will be there. And whenever you will try finding the ratio between, suppose here also we are calling it first term, here also we are calling it second term, this is the third term, this is fourth term, this is fifth term. Here when you will check the ratio between second term to first term, okay, you will be getting 4:2, and that means 2:1. When you will check the ratio between third term to second term, you will be getting 8/4, and that means again 2/1. Okay, so each time you will be getting the same ratio. If that is the case, then your sequence is in GP, geometric progression. Okay, one more way is there to identify it. Every time a certain number will get multiplied in your sequence, that's why the ratio is coming same. Okay, so you can see 4 2 times 2 2 times 4, 4 2 times 8, 8 2 times 16, 16 2 times 32. That's what happened in GP. How the moment you saw the sequence which is in AP, you realize, okay, a certain number is getting added every time, or maybe getting subtracted every time. That's in AP, but the rule says don't go that way. The rule says just do the subtraction: A2 minus A1, A3 minus A2. Okay, that will give you the common difference. Here this way we will be checking always this ratio between second term to first term, the ratio between third term to second term, the ratio between fourth term to third term. If all the ratios are same, then we will say yes, the given sequence is in GP, geometric progression, and the ratio which we have obtained, this 2/1, 2/1, and the next will also be 2/1. You can check it. Okay, 32/16, it will be 2/1. So this ratio is called common ratio. There we were saying common difference because we were doing the subtraction. Here we are going to call it common ratio. And here common ratio is 2/1. 2:1, 2/1. That's the common ratio over here in GP. Now, how everything is similar, just like AP. First term is A1, next term is A2, next term is A3, next term is A4, next term is A5. Okay. Now, if I am writing again the same sequence, that is 2 is there, then 4 is there, then 8 is there, you can check it. It is not in AP. If you are thinking in AP also I am giving the same example, in GP also I am giving the same example, so please take a pause. I am not giving same example. Yes, the number may look same, but if you will check the difference, 4 minus 2 2, 8 minus 4 4, is it in AP? Is it in AP?
Can you repeat, ma'am?
It's not in AP. Okay, it's not in AP. Yes, it is in GP. GP means the ratio will be same. Just now we have checked, the common ratio will be getting over here, and if the ratio is same, then there comes a term common ratio, and then we will declare, yeah, it's in GP. Okay, so yes, this is in GP. And just a moment, here also we will be calling the first term as just a small letter A, just A. Okay, the next term will be called, you can see the next term you got how, by the multiplication of 2, right? Next term you got by the multiplication of 2, next term you got by the multiplication of 2, and what are we getting as a common ratio? R. Okay, R, what are we getting as a R over here? when we are finding r second term by first term, that is 2 is to 1, right? Which can also be written as just 2.
Yes.
So can you see the next term 4 can also be written as a multiplied with r? Can I write a multiplied with r? That will give you the second term. Yes or no? Forget about this, all the things.
Yes,
Just see
ma'am.
the numbers and tell me. Yes, Manvi. Can I write the second term as a into r? Your a is 2 and your r is 2. So can I write the second term as a into r? Yes or no?
Yes, ma'am.
Okay. Let me show you the next term. Can I write the next term, the third term, as the previous one multiplied with r? Check it. Previous one was 4 multiplied with r. Yes, that is 8. Yes or no?
Yes, ma'am.
Getting it, Manvi?
Yes.
Okay, so if you are thinking what I'm trying to explain, I'm trying to explain from here we are observing that a is 2, ar is 4, and the next term is 8. So can I write ar into r? We can write it, right?
Yes.
Similarly, it became ar square. You can check it. Next term will be the previous one, this one into r. Okay, so here your sequence will progress in this way. First term is a, next is ar, next is ar square, next is ar to the power 3, next is ar to the power 4. It will progress like that. Let me help you recalling the previous concept in AP, how you identified that first term is a, next term is a plus d, next term is a plus 2d, next term is a plus 3d, next term is a plus 4d. Okay, just a moment. So the way we were saying in AP, the first term is a, next term a plus d. How a plus d? Mathematicians has told us, yes, but we realized also over there that every time d is getting added, even though our d is negative or positive, every time d is getting added. So here we are realizing every time r is getting multiplied, every time r is getting multiplied, every time r is getting multiplied, and hence we are getting this pattern which mathematicians has given us, but we are feeling it by ourselves also. We are realizing, yeah, this is going on. First term is a, and next time we ended up getting 4. That means a into r. Next time we ended up getting 8. That means the previous term multiplied with r. Again we ended up getting 16. That means the previous term multiplied with r. And from there we got a general form of GP, that is ar square, ar cube, ar to the power 4, ar to the power 5, ar to the power 6, like that. Getting it, Manvi and Nabila?
Yes.
Yes, ma'am.
Okay, so our general form of GP is first term is a, next term is ar, next term is ar to the power 2, next term is ar to the power 3, next term is ar to the power 4, next term is ar to the power 5, next term is ar to the power 6. You can see the first term. Okay, first term, how many r is there? What is the power of r? Nothing. In first term, what is the power of r? Nothing. That means r to the power 0 is there. In second term, you can see r to the power 1 is there. In third term, you can see r to the power 2 is there. In fourth term, you can see r to the power 3 is there. In fifth term, you can see r to the power 4 is there. In sixth term, you can see r to the power 5 is there. In seventh term, you can see r to the power 6 is there. In eighth term, you will having a r to the power 7. Are you getting it?
Yes, ma'am.
Okay. 11th term will be a r to the power 10. Yes or no?
Yes, ma'am.
Manvi, are you able to understand the
Yes.
pattern?
Yes.
Second, second power 1. Third term power 2. Fourth term power 3. Fifth term power 4. Sixth term power 5. So 11th term power 10. Okay. 100th term a r to the power 1 less power than 100. That means 99. Getting it, Manvi?
Yes, ma'am.
Okay. 1000th term a r to the power 1000 minus 1. That means 999. Okay. Similarly, nth term a r to the power n minus 1. Are you getting it, Nabila and
Yes,
Mom?
ma'am.
Yes, ma'am.
Okay. Every time this in this general form, when we are trying to understand the pattern, actually it is pattern based question. Okay, when we are trying to identify the pattern, we are noticing at first, look, for the first term power is r, there is no r. That means r to the power 0 is there. For second term, we have seen r to the power 1 is there. For third term, r to the power 2 is there. For fourth term, r to the power 3 is there. And hence we realize, okay, whatever is the term, okay, the placement can be 200th place or 192th place or whatever be the place. Here r will be one less than that. One less than that. The power of r will be one less than that. And yeah, a will remain as it is. We have identified this pattern, and on the basis of that we are saying that nth term formula is a r to the power n minus 1. Are we making the formula by ourselves? No, this formula is given to us. In your book, it is written that nth term of a nth term of a GP formula is AR to the power n minus 1. But are you feeling it also? Are you able to understand the pattern that, yeah, from here only we are getting, all of sudden it doesn't came from anywhere?
Yes, ma'am.
Yes, ma'am.
Got it, Manvi?
Yes, ma'am.
Okay. So from now onward, we will keep the note that nth term of GP formula is AR to the power n minus 1. What is A? First term. What is our common ratio? What is n? The placement. Okay, let's do few basic questions, then we'll be moving with the level 2 questions. Find 10th term of GP okay. We don't have to check whether it is in GP or not, because it is in GP, which is given in the question. And what we have to do, we have to find the 10th term. The way you were doing everything in arithmetic progression chapter, exactly like that we'll be doing everything over here, but just the terms are different. Okay, and a few logics and everything, those things are different, but our a will be writing the first term a only, and if we have to write the first term, second term, third term, we will be writing it a1, a2, a3, just like AP. Okay, so we have to find the 10th term over here. We will say nth term. Okay, nth term of GP formula is an formula is a r to the power n minus 1. This is a formula over here. Okay, here we know the a value. Okay, we know a over here is 5 and r over here is, r means common ratio. R means common ratio, second term divided by the first term. That means our common ratio is 5:1, which can also be written as just 5. Getting it?
Yes, ma'am.
We will be using the formula of nth term of GP. That means 10th term will be A is 5 into R. R is also 5. N minus 1, that means 10 minus 1. Okay, which will be 5 into 5 to the power 10 minus 1 will be 5 to the power 9. Now you can use law of exponent, which says that when multiplication is there and the bases are same, you have to add the powers. That means you will be having 5 to the power 1 plus 9, that means 5 to the power 10. Yes, you don't have to do the calculation. When it's just 5 to the power 2, 5 to the power 3, then we will try finding the final answer. But when the power is such bigger number, then we will leave the answer this way. And we are done with finding the 10th term of GP. Is it clear?
Yes, ma'am.
Yes, ma'am.
Let me take another question. Just a moment. So the next question is, find 20th term of GP. 5 by 2, 5 by 4, 5 by 8, like that. Okay. So 20th term we have to find over here. 20th term we have to find over here. We are already having a GP. We don't even have to check whether it is in GP or not, because the question says it's in GP. Okay. So again, the same formula, A20. A20 we have to find. That will be A R to the power N minus 1. A, okay, R to the power. Our A is, let's take directly. The A is 5 by 2, the first term. R is common ratio. Common ratio means second term divided by the first term. Second term divided by first term. Now this division must be clear to you, because in your previous class you have done so many calculation and much more trickier calculation than this one. This is not a fraction by fraction, is not a big deal for you. Can you tell me what are we going to get as a r?
1 by 2.
1 by 2 will be having 5 by 4 into 2 by 5. Yeah, we'll be having 1 by 2, right, Manvi?
Yes, ma'am.
Okay, a r to the power n minus 1. Our a is 5 by 2. A r, what is r? 1 by 2 to the power n minus 1. What is n? N is the placement. 20th term we want to find. So 20 minus 1. 20 minus 1. That means the power of 1 by 2 will be 19. And here we'll be having 5 by 2. We will not leave the answer like this. Whatever little bit simplification is possible, yes, by using the law of exponent, we will perform that. So what we will do, 5 by 2 will remain as it is, and there 1 by 2 to the power 19 means 1 will take the power 19 and 2 will also take the power 19, right?
Yes, ma'am.
And we will be having 5 by 2 into 1 by 2 to the power 19. Now you can see in the denominator, In numerator, you are having just 5, but in denominator, this 2 into 2 to the power 19 you are having, which together will be 2 to the power 20. 5 by 2 to the power 20. Got it?
Yes, ma'am.
This is how we are doing the simplification. Now, if it says that find 20th term and also find the nth term also you have to find. So whenever the question says find the nth term, please don't get confused. You just need to put the a value as it is. A and R. You know your R is 1 by 2 to the power n minus 1. What is your n value over here? Nothing. It's just given n. So you will be writing n minus 1. So whenever in any of the question it says find the nth term, that means the question is telling you just put your a value and R value. And whatever you are getting, just write your answer as it is. So you will be getting nth term of the same GP. You can see everything I have just substituted except n, because nth term n will remain as it is. Okay, so 5 here also we will distribute the power 1 by 2. 1 will take the power n minus 1 and 2 will also take the power n minus 1. Please don't get confused with this n. 1 to the power anything is just 1. So it will be just 5 into 1. That means just 5 in the numerator. And in denominator, again the same thing. 2 into 2 to the power n minus 1. You know, when we are having multiplication, then we need to add the exponent. When you will add this two exponent, you will be getting just 2 to the power n. Yes or no?
Yes, ma'am.
Is it making sense, Manvi?
Yes, ma'am.
Okay, so this way the question will be given to you to find the 20th term and also find the nth term, to find the 5th term and also find the nth term of the GP. So nth term is just keep your n as it is. Now the next one, find the 12th term of GP whose 8th term is 192 and common ratio is 2. You have to find the 12th term. 8th term is already given. That means A8 is already given to you as a 192 and common ratio R is also given to you as a 2. A8, what is the formula for A8? A8, if you have to find manually, then you must, okay, you will be using AR to the power n minus 1, right? That means A R to
Yes,
the power
ma'am.
8 minus 1, that means 7. Now A8 value is given to you, that is 192. Getting it, Manvi and Nabila?
Yes, ma'am.
Yes, ma'am.
Okay. So we are just substituting. A we don't know. R we know it is 2. This R we are going to place 2 to the power 7. Be careful while taking the exponent. This is just R to the power 7. Just common ratio to the power 7 you are having. Okay. So bracket is important. Now from here you have to find the A value. How? Just this 2 to the power 7 will go in the denominator of 192 like this. Yes, we are okay. The question is expecting you to do a little bit of simplification, whatever possible over here. So you will be doing A is equals to 192 by 2 to the power 7 like this. Okay, now you can factorize 192 to check how many 2's are there. That will be the better way to deal with it rather than multiplying 2 into 2 into 2 into 2 in the denominator and then thinking how to do the cancellation. Or maybe you can do like this also. 2 to the power 7 means 2 into 2 into 2 into 2 like this. Okay, 1, 2, 3, 4, 5, 6, 7. And here we are having 192. Now keep on cancelling. 2, 9 times 18, 2, 6 times 12. Okay, 2, 4 times 8. 2, 8 times 16, 2, 2 times 4, 2, 4 times 8. Okay, 2, 1 times 2, 2, 2 times 4. You can do this way or you can just do the factorization of 192. Okay, like this. And you will be getting 2 to the power whatever into 3 into that. Now you can just cancel out the denominator's power of 2 with the numerator's power of 2. Whatever is getting cancelled out. Getting it?
Yes, ma'am.
So we are getting just 3 by 2. Okay, we are getting just 3 by 2. What I am talking about, if it is not making sense, I am saying do the factorization of 192. You'll be getting 2 9 times 18, 2 6 times 12, 2 4 times 8, 8 times 16, 2 2 times 4, 2 4 times 8, 2 1 times 2, 2 6 times 12, and then one more 2. 3 times 6. So how many 2? 1, 2, 3, 4, 5, 6. We are having 2 to the power 6 into 3 in the numerator. 192 can be written as this one. And the denominator is 2 to the power 7. 2 to the power 7. Clearly, can you see that 2 to the power 6, 2 to the power 6 gone, and we are having 3 by 2 as an answer. Clear?
Yes. Yes.
So either you do that way or you do this way. It's completely up to you. Yeah, you can do both. Now it says the fifth, eighth, and 11th terms of a GP are P, Q, S respectively. Show that,
Ma'am, in the previous question, find 12th term is asked, right?
yeah, it's from our book. Yes, fine, 12th term. Okay, we have still now not found the 12th term. Yes, but now we know A and R are already given to us. A we found 3 by 2. We will be able to find the 12th term, right, Nabila?
Yes, ma'am.
Yeah. Okay. So yes, please finish it. These questions are from your NCRT only. The fifth, eighth, and 11th term of a GP are given to us as a PQS respectively. Show that Q square is equals to PS. Okay, we don't know how to prove it. Here, so many proof-based questions we will do, and every time we will ask ourselves what to do over here. And every time, if the answer is we don't know what to do, then just follow the rule. I mean, follow the question. That fifth term, eighth term, 11th term is PQS. Fifth term is P. A5 is P. Okay, A5 formula is A R to the power n minus 1. R, n we know 5, that is 5 minus 1, that means 4. That is P, right, Nabila?
Yes, ma'am.
Okay, eighth term is Q. That means eighth term is A R to the power n minus 1. 8 minus 1. That means for eighth term, can I write A R to the power 7? That is Q.
Yes, ma'am.
And 11th term can be written as, okay, that is S. So A R to the power n minus 1. A R to the power 11 minus 1, that is 10. That is S. Now we are having three equations, you can say. And something we have to prove it. So we don't know how to do the proof. So we will be going, let's take the left hand side, let's put the value, let's take the right hand side, let's put the value, let's check by doing the simplification that left hand side's answer and the right hand side's answer is coming same or not. Making sense?
Yes, ma'am.
Okay, so yeah, you will be getting both sides same. Can I leave it? You can check it. Q square when you will do, here only I am showing it to you. Q square is PS, no? So when you will do Q square, just a moment. So when you will do Q square, you will be getting this. That means A R to the power 7, that is square. Now law of exponent says that just distribute the power. A will take the power 2 and R to the power 7, that will also take the power 2. Right? right,
Yes,
Nabila?
ma'am.
We'll be having a square,
Yes.
and 7 exponent is 7 also, 2 also. Law of exponent says that if a to the power m and then power n is there, that means a to the power m into n, right?
Yes, ma'am.
That means r to the power 7 two times. This is what we are getting from q square. We are still, okay, we don't know what to do after this. So we are trying to find ps. Q square we have found. Now p into s we will try finding. If both the answer will be same, then we can say that, yeah, left hand side and right hand side are equal. So p is a r to the power 4 and s is a r to the power 10. Again, law of exponent. You will find that here every time, everywhere we are using law of exponent because of the exponent. Okay, r, the common ratio will always be having this exponent, that exponent, and we will just always use the laws and properties of exponents. So you can say a is here, a is here, both multiply together, will be having a square. Then we can see r to the power 4 is here, we can see r to the power 10 is here, both will sit together. Actually, all are in multiplication with each other. A r to the power 4, a r to the power 10, all are in multiplication with each other. This term, this term, this term, this term, all are just multiplied with each other, right? So even though we are just changing their places, doesn't matter at all, right?
Yes, ma'am.
Okay, so r to the power 4 into r to the power 10, we can write it this way, and both r to the power 4 and r to the power 10, 4 and 10, this both will just collaborate together and will be having 4 plus 10, that is 14. We are having a square r to the power 14. Our LHS is same as our RHS. Is it clear?
Yes, ma'am.
Manvi and Nabila.
Yes.
Yes, ma'am.
Okay. Yes, Manvi. Same type of questions we are having in both of your books. We are having same types of question. I have taken the all the types which is common in both the books. Now, Manvi, I'll show you few questions, okay, which is extra in your book. I'll show it to you. That's from AP. So I will show you. AP, you already know the concept, just the level of question, okay, here and there. So I'll show you those concepts. Now, AP, GP, everything is mixed up in both the, like, both of your books. So we are discussing it. Okay, you will find that most of the question you are able to now understand, at least GP, the basics of GP. Still, I have not introduced you the sum of n terms of GP. Today we are only discussing the basics, that means questions and concepts related to nth term of GP. Okay, now if we are having the summation, okay, here the question is evaluate the summation of 2 plus 3 to the power k, which I was telling you just now, and k is starting from 1 and ending at 11. We understand it. We understand it really well. Okay, let's expand it and let's try finding the sum of this series. Okay, so we'll be having 2 plus 3 to the power k is there. K is starting from 1 and ending at 11. So we'll be having 3 to the power 1 plus 2 plus 3 to the power 2 plus 2 plus 3 to the power 3 plus 2 plus 3 to the power 4 plus 2 plus 3 to the power 5, okay, plus 2 plus 3 to the power 6, and like that, just keep on going and keep on going. 2 plus 3 to the power 11. Making sense to both of you?
Yes, ma'am.
Okay, we have to do the calculation now. Okay, writing from here to here, you already understood. Now let's do the calculation. So be careful. You are having 1, 2 over here. Then again added 2, added 2, added 2, added 2, added 2, added 2. So can I say 2 plus 2 plus 2 plus 2 plus 2 plus 2?
Yes, ma'am.
11 times we'll be having. 11 times. Can I say?
Yes, ma'am.
Can I write it directly as a 11 into 2? Yes or no?
Yes, ma'am.
Getting it, Manvi?
Yes, ma'am.
Okay, now this one, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, 3 to the power 5, 3 to the power 6, 3 to the power 7, 3 to the power 8, 3 to the power 9, 3 to the power 10. Let's write it. After this, one added version is there, and that is containing 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus 3 to the power 4 plus 3 to the power 5, and like that, just continuing till 3 to the power 11. Now the first part is sorted. 11 into 2 is 22, but the second part, how to add them all, it will be okay. So it will take so much time. It will be really calculative how to do that. Okay, 3 to the power 11, you can understand. First you will be multiplying, and then you will be adding all of them. Okay, at least half an hour we need to do the calculation for the second part. If we don't know any rule, any logic, then half an hour we need to give for doing this much of calculation manually. Okay, but we just now we are covering GP, geometric progression, and we discussed that every sequence where the ratio is same, that means the second term by first term, when you will try finding second term by first term ratio, that will be 3 to the power 2 by 3 to the power 1, that means just 3. If this one, then the ratio between third term to second term, that is 3 to the power 3 by 3 to the power 2, that is 3 to the power uh, 3 is there, 2 is there, 3 to the power 1. Okay, that means the next term 3 to the power 4 by 3 to the, just a moment, a4 by a3. Okay, the ratio we are checking whether it is in GP or not. If it is in GP, then there is a sum formula. Okay, I'll just skip this question for now, because for now I am not introduce you the sum formula. There is sum formula just like AP. In AP the sum formula Sn was n by 2 2a plus n minus 1 into d, right?
Yes, ma'am.
Here also we are having a sum formula, but at first I am trying to cover all those questions which is related to nth term. Okay, so I'm just I'll take a pause over here. Just keep it in your mind. Again we will come back to this question. The moment we will discuss the sum formula, we will come back to this question and we will finish it. Okay, it is in GP, you can check it. 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3. Okay, this is a series. This is a series associated with the sequence. Actually, the sequence is 3 to the power 1, comma 3 to the power 2, comma 3 to the power 3, comma 3 to the power 4, comma 3 to the power 5. This is a geometric progression, a geometric sequence we are having. Okay, and the same, a series associated with this sequence is given to us in, that we can see in front of us, right?
Yes,
Right?
ma'am.
And we just have to find the sum of the series by using the sum formula of GP. Okay, sum formula, there is Sn formula over here also, but for now let's cover the nth term formula. So far it is clear, right?
Yes, ma'am.
Okay, let's move. Now here you will also find some question which is like this. Just a moment. If fourth, 10th, 16th terms of GP are X, Y, and Z respectively, prove that X, Y, Z are in GP. We need to understand the question. Okay. Let's see what the question is trying to say. If the fourth term is x, 10th term is y, 16th term is z. Fourth term is x, 10th term is y, 16th term is z. Then prove that x, y, z are in GP. X, Y, Z, or maybe A, B, C, or maybe A, B, C, D, or maybe anything is in GP only when the ratios are same. Ratio means, okay, suppose it says that x, y, z are in GP. The moment we are reading this one thing is clicking in our mind that here we don't have learned so many logics and concept. We just have learned GP means the ratio will be same. Ratio means ratio between the second term to first term. That means y by x. That ratio must be same as the ratio between third term to second term. That means z by y. If that is the case, then only we can say it is in GP, right?
Yes, ma'am.
If I will tell you that A, B, C, D are in GP, that means the ratio between B by A must be same as the ratio between C by B, must be same as the ratio between D to C. Yes or no?
Yes, ma'am.
Apart from this one, I have not explained anything over here. It's just a pattern, a very basic pattern which is following a certain condition. Nothing else in, okay, in detail, in depth. We don't need to understand anything over here. Just the ratio needs to be same. The sequence is in GP. Okay. So if it says prove that X, Y, Z are in GP, so we will try finding the ratio. How? Y by X, Z by Y. We will check both the ratios are same or not. If it is same, then yeah, it is in GP. Let's see that. Fourth term is X. Okay. So A4, that is X. For fourth term, okay, if we have to find the fourth term by using nth term formula, it will be AR to the power n minus 1. Fourth term will be A r to the power n minus 1. A is given? No. Common ratio is given? No. So we will be assuming that first term is a small letter a, common ratio will be representing by r only, and the fourth term will be A r to the power 4 minus 1, that is 3. That is x. Getting it?
Yes, ma'am.
Okay. 10th term, A10, that is y. That means now 10th term according to the formula is A r to the power n minus 1. A is A, r is r, 10 minus 1 will be 9. That is y. Equation number 2. Making sense?
Yes, ma'am.
Similarly, 16th term is given to us as a z. So we will be writing A r to the power n minus 1. That means 16 minus 1 is 15. That is z. And we are having 3 equation in front of us. Now we have to say x, y, z are in GP. X, Y, Z are in GP means ratios has to be same. What ratio? Y by X. If X, Y, Z are in GP, if we have to prove, this is in rough part I am writing. Okay, if you have to prove X, Y, Z are in GP, okay, this manner, then that means Y by X, you will find the ratio and you will check Z by Y. Both the ratios are equal or not. So let's find the ratio. Let's find the ratio. Now Y by X is equals to a r to the power 9. Y is this one. And x is a r to the power 3. Any confusion so far?
No, ma'am.
Okay. A gone. R to the power 9 by r to the power 3. 9 minus 3. 6. We are getting this one. Okay. So, we will just keep it as it is. Now we are going to check the other one. That means z by y. Okay. Even though you are not getting a particular value, still we are fine. Okay. We are going to check what about z by y. So we'll be taking z a r to the power 15 and y is a r to the power 9. A gone. 15 minus 9 r to the power 6. Now, can we say that y by x is same as z by y? Hence, x, y, z are in AP. I mean, sorry, my bad. It's in GP.
Yes.
Okay, so the question, the moment you will be able to understand the question really well, then you will be able to figure it out what you have to do over here. X, Y, Z are in GP. That means, okay, we will say that here Y by X is equals to Z by Y. Hence, X, Y, Z are in GP. Proved. Any confusion so far?
No, ma'am.
No, ma'am.
If the first and nth term of GP are A and B respectively, and if P is the product of n terms, prove that P square is equals to AB to the power n. If you are thinking that what exactly is given in the question, we are not getting anything, let's try decoding this mathematical language. Okay, so it says that if the first term and nth term of a GP are A and B, okay, so it's written that the first term is A and nth term, that means an, this nth term, that means which we write always as a r to the power n minus 1, that is given as a B, right?
Yes, ma'am.
Okay, so far we are getting it. Now in question it is written that if P is the product of n term, product means multiplication, product means multiplication. So it says that P is the product of n terms. That means if we are thinking about GP as A1, A2, A3, A4, A5, okay, just like that AN. Then P is the product of n terms, which we also write. A1 we write as a A2 we write as a into R. Okay, A3 can be written as AR square, and A4 can be written as AR to the power 3. A5 can be written as AR to the power 4. Are you getting what I am writing over here?
Yes, ma'am.
So here it is written in the statement, okay, which for the very first time we are seeing such question, and it is written that product of n term. So when the moment it says product of n term, we are just writing it as it is, even though we don't know what to do after this one. We are just writing it as it is, that product of multiplication between all the term, that is given to us as a P, right?
Ma'am.
Okay, now we know that A1 means just A. Okay. A2 means just A into R. A3 means AR square. A4 means AR to the power 3. A5 means AR to the power 4. A6 means AR to the power 5. Dot 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 AN means AR to the power n minus 1. Have we done anything yet which is not that clear to you? Okay, the step is not at all making sense to you. Have we done anything so far?
No, ma'am.
Are you getting it, Manvi?
Yes, ma'am.
It says that the first term is A, we have written. It says that the nth term is B, we have written. It says that the product of n term. Product means what? Product means multiplication. Multiplication of all the n term is P. We have written it. Now we don't know what to do. Okay, I don't know what to do. But I can see A is here, A is here, A is here, A is here. Just like that summation one, at least we are able to apply the logic that A. Okay, how many A we are having? So here the power is, okay, 1, then again 1A, 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 1A. So can I write n, A to the power n we are having? Can I write A into A into A into A? If you are having A into A, you will write A to the power 2. If you are having A into A into A, you will be writing A to the power 3. If you are having A into A into A into A, you will be writing A to the power 4. But here you are having A into A into A into A into A into A till nth term, starting from the first term. So can I write A to the power n? Can I?
Yes, ma'am.
Getting it, Manvi?
Yes, ma'am.
Product is there, hence the power. And all are having just power 1. That's why we are writing it so easily. Here A, here A, here A, here A. Okay, the power is not changing. If the power will be changing, then we won't be able to write this way. Okay, look at your R. That is changing. Okay, so we are writing this way. Now, R, if you will look closely, you are having R into is there. But the R, okay, just you are having R to the power 1 plus R to the power 2 plus, sorry, multiplied into R to the power 3 into R to the power 4 into R to the power 5 into R to the power 6 dot 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 R to the power n minus 1. Yes or no? Can you see that?
Yes, ma'am.
So far we have not done anything, okay, which we are not understanding at all. But yeah, forcefully we have to do this way only, because this way we'll be getting the answer. No, whatever we are understanding, we are doing it. Okay, now law of exponent says that if you are having a to the power m into a to the power n, you have to add the powers. If you are having a to the power m into a to the power n into a to the power p, you have to add the powers. How? A to the power m plus n plus p, like that, right?
Yes, ma'am.
Right. Okay, so this rule you have seen for only two terms, but it can be, okay, we can use it for any number of terms. If the bases are same and the numbers are in multiplication, then you can add the powers. Are you getting it?
Yes, ma'am.
Okay,
Yes.
so what we are using, law of exponent we are going to use, that r to the power 1 into r to the power 2 into r to the power 3, that means r to the power 1 plus 2 plus 3 plus 4 plus 5 dot 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 n minus 1. Clear?
Yes, ma'am.
That is
Yes.
p. Okay, we have not done anything which is not clear to us so far. Now in class, you can see this is in. Have you learned a formula in class 10 that sum of first n natural number will be n into n plus 1 by 2? In arithmetic progression, there was a little brief that Gauss has given us. Someone asked the Gauss. This is the story of class 10 arithmetic progression chapter. That there was mathematician named Gauss, and someone asked him that what is the sum of all the natural numbers starting from 1 to 50. Okay, then what he did, he just arranged the number like this, and then he said again I will write it like this, And this time I'll be writing 50 first, then I will write 49, then I will write 48, then I will write 47, and like that I will continue till 1. So that's why both are exactly same. Okay, if Sn is 1 plus 2 plus 3 plus 4 plus, okay, dot 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 50, then the same Sn can also be written as 50 plus 49 plus 48 plus 47 plus dot 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 1. Yes or no?
Yes, ma'am.
Right? Okay, then what he did, he has just added this 2, and he said 2 times Sn is equals to 50 plus 1 will be 51, 2 plus 49 will be 51, 3 plus 48 will be 51, 47 plus 4 will be 51, and like that all the number will be 54. Okay, I mean 51. He has just taken the pairs and just added them like that. And what he did after that, he realized that 51 plus 51 plus 51 plus 51, how many times we are having, you can check it. The first time, the first series which you can see, 1 plus 2 plus 3 plus 4 plus 5 till 50, how many terms are there? 50. In the next one, same thing we have written, and that too, 1 plus 2 plus 3 plus 4 till 50. There are also 50 terms we are having. But the moment when you are adding this two equation, you have taken pair together. Okay, the pair together, pair together, pair together, pair together. So can I say 50 times 51 we are having? Can I say 50 times 51 we are having? Yes or no?
Yes, ma'am.
This all the things, we don't need to know this story. This things has been done by Gauss, and he has given us a formula. I was just about to take the formula directly, but then I taken the whole story that he said that it will be 51 into 50. Sn will be 51 into 50 by 2, and from there comes a rule that if we have to find the sum of first 50 natural number, then it will be, okay, n plus 1, n into n plus 1 by 2. That means 50 into 50 plus 1 by 2. That means this will be 50 into 51 by 2. This is the formula for finding the sum of first and natural number. If you want to add from 1 to 20, then you can use this formula. If you want to add from 1 to 50, then you can use this formula. If you want to add from 1 to 1000, then you can use this formula. 1, starting from 1, then till 1000, if you want to add, then only you can use this formula. But if you are telling me that no, 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 I want to add all the numbers from 50 to 100, then this formula is not applicable. This formula is only applicable when you are trying to add from 1 till any number. Getting it?
Yes, ma'am.
Okay, this is the formula for sum of first and natural number. First and natural number. That means if you want to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this formula. Okay, 1 to 20, this formula. 1 to 30, this formula, without skipping a single number. Okay, continuously if you want to add natural numbers starting from 1 till any number, then you can use this formula given by Gauss. Okay, these things are there in class 10. From here only we have also obtained the sum of n terms of AP also. Okay, so just keep it in mind, there is a rule that sum of first and natural number is n into n plus 1 by 2. N into n plus 1 by 2 given by Gauss when he was just 10 years old. So can you see we are having sum of 1 plus 2 plus 3 plus 4 plus 5, okay, till n minus 1. I'm telling you the sum of first and natural number, okay, till any number you want to add, you can add it by using this formula. So can we use this formula that r to the power, we have to find the summation of all. So n into n plus 1 by 2. The formula is n into n plus 1 by 2. But here our n is this one, right? The last term is this one. So at the place of this n, I'll be writing n minus 1. At the place of this n, I'll be writing n minus 1 plus 1. Getting it?
Yes, ma'am.
Okay. So actually it will become n minus 1 into n by 2. Is it making sense? Nabila and Manvi.
Yes,
Yes, ma'am.
Okay, n minus 1 into n by 2. Directly I am writing the sum is n minus 1 into n by 2. From where? From the same formula, n into n plus 1 by 2. Okay, when your n is 50, you need to put 50 over here. When your n is 40, you need to put 40 over here. When your n is k, you need to put k over here. When your n is r, you need to put r over here. When your n is n minus 1, you need to put n minus 1 at the place of n over here. Okay, a to the power n into this one is equals to p. Now just see the proof part. Here we have to show that p square is equals to ab to the power n. So there are two ways to do it. Okay, if still one, by doing the arrangement, we have to prove that p square is ab to the power n, a into b to the power n. This is our p. This is our p. And we have to show that p square is ab to the power n. So what we can do, we can do the squaring of p. And we can check, are we getting the same or not? This is our p, right? When you will do p square, let's check what are we getting. So everything, whatever we are having, everything is square, yes or no? That means a will take the power, r will also take the power. Okay, if two powers are there, three powers are there, we do the multiplication of between the powers, right? Nabila and Manvi.
Yes,
yes, ma'am.
ma'am.
Okay, 2 gone. We are having a to the power 2n, r to the power n into n minus 1. But we have to say p square is ab whole power n. So just take the power n common from both of them first. Why? Because the proof is containing power n out. So we'll be just having a square and we'll be having r to the power n minus 1. Making sense?
Yes, ma'am.
Okay. Now ab to the power n is there. So one a we are keeping it separately and the other a we are writing this way. Can you see this is b and this is a and we got the proof? Getting it? It was given in the question that the first term is a and another term is a r to the power n minus 1, nth term is b. It was already given in the question. Getting it?
Yes, ma'am.
We are done with the proof. We have not done any arrangement except that formula you have seen for the very first time. And if you have seen that formula in class 10, great. If you don't know this formula, then you can find the sum of all the terms of AP from 1 to n minus 1. Okay, if this formula you are not able to, okay, you are thinking that from where all of sudden a formula came, then I am telling you just add them 1 plus 2 plus 3 plus 4 till n minus 1. This is in AP, right? The common difference is 1. Yes or no? Right?
Yes, ma'am.
And Sn will be n by 2. Your n is this one, 2a plus n minus 1. Okay, n minus 1 you will do n minus 1 into d, this one. What are you going to get? Outside it's n minus 1 by 2 and here you are having 2 plus n minus 2. Can you see? Same thing, you got n into n minus 1 by 2. Directly you got the formula which we have written in the power. I am talking about this